Assalamu alaikum engineers. Today we will be doing a tutorial for HAP for primarily for load calculations, and the layout which is selected, the structure which is selected for this load calculation is our very own NUST SMME auditorium. The building layout, or should I say the HVAC layout, because ducts are also showing up, so is open right in front of me. We are on the third floor, and you can see this is our auditorium, and ducts are going. This is the podium, and over here the sitting arrangement. Ducts are coming out of a chute, and over here, so it is coming out of a chute and it is extending throughout the auditorium. And when we go on the roof plan, we see that two AHUs of fresh air AHUs of 15 tons each capacity are installed to serve this auditorium. So moving forward, you can see the area of this auditorium is 46.5 feet on in the width, and height and length is 51 feet. So let's get started. I have opened up HAP, and the very first thing to do is go to preferences and uh, select the standard on which you want to base your study. So the latest standard which is available in my version of HAP is 2010. So let's go with this. Okay. After that, it is very self-explanatory graphic user interface. So considering the first thing first, the weather data, the design conditions. So for weather, we will select on weather, and now it would ask us about the region. Okay, it is important to note that only in HAP Pakistan lies in Middle East. Pakistan is not in Middle East, it is in the South Asia region, but they have clubbed Pakistan into Middle East. So from here you will select Middle East, and then you will select Pakistan, and the only city which they have added in their library is Karachi. So no worries there, you can add Islamabad manually like I am doing. After that, you need to provide the latitudes and longitudes. So I have written the longitude latitude over here for our auditorium, and if I type the same into Google, I will exactly reach on the auditorium location. Let's actually see that in satellite view. So somewhere over here is our auditorium, the location selected for the HVAC load calculation, and these are the latitudes and longitudes. So taking these longitudes and latitudes, we copy it. This is the latitude, and paste it over here, and similarly we take the longitude and we paste it over here. It is rounding it off, but no issue. The data is stored in the full form, but it is just showing in the to one significant figure, but the data is stored over there. So next step is the elevation. For that, I have also shared the link in the slides. You can go on to our website which is called Elevation Finder, and all you need to do is just type in the longitudes and latitudes like I have already typed in, and it is telling me that the location is 1816.2 feet above the sea level. So it's better to take, you can also take the elevation from design conditions, but it is a good approach to actually find out the the actual elevation and then put it in the uh, user interface of HAP. So 1812.2. I hope I have got it. 1816. Okay, let's be very specific. Although this won't affect that much. But next is the summer design dry bulb condition. For that, Shrey and often publishes the design conditions for HVC design engineers. I have one copy here opened in my PC and I will be opening that. Okay. So coming towards the hot annual cooling condition, the dry bulb is 41 degrees Celsius. This is written in Celsius. So let's convert Celsius to Fahrenheit. So it is 105.8. So let's plug it in. 105.8. Okay, now summer coincident wet bulb temperature, that was around 22.6. So again, find it out. That's 72.68. And that was 72.68. So let's plug that in as well. 72.68. Then the daily range is 13.5 as we have just seen in the design range. Okay, over here 0.4% is written. So the meaning of this is that these design conditions are good for the entire cooling season, that would be summer, and only 0.4% of the time these the conditions exceed these values. So it is a good way to use it is a good approach to use these conditions for your load calculation in HAP. So 13.5 is the hottest month dry bulb range and it is plugged in. Similarly, for wet bulb design, winter design dry bulb, the heat we will go to heating, and again 99.6% is written. This means that throughout the winter, which is the heating season, only these conditions remain valid from for 99.6% of the times. So only 0.4% of the times these conditions the temperature goes even lower. So this is again written in Celsius. Let's convert that. Not an issue. 2 degrees Celsius is 35.6 Fahrenheit. Let's take that, plug it in. Okay, now we are into a bit of trouble because the software is asking for winter coincident wet bulb temperature, whereas in our design conditions we won't be finding that specific acronym, mean coincident wet bulb. This is mean coincident wind speed, by the way, so this is not useful. So what we will do is we will take the knowns and we will try to find the unknowns, as we have been doing for quite some time now in our engineering course. So let's take the dry bulb temperature of 2 Celsius and dew point of minus 4.9. And again, I will be sharing this website. There are so many online psychrometric calculators. You can use any of that. So 2 degrees Celsius is added up here, and dew point of 4.9 minus 4.9. And then you need to zero other values, minus 4.9. Okay, where here we need to specify the elevation as well. So the elevation was in feet, but here it is needed in meters, so 553.6 meters. And let's calculate. So the wet bulb temperature comes out as minus 0.66. Again, convert it, 30.812. So These values are pretty much default. Atmospheric layers number, it is often varied when the conditions are cloudy, and ground reflectance of 0.2 and soil conductivity that could be taken. However, you do need to change the time zone because we are into +5 time zone, and there is no trend of daylight saving, so we are good to go. We have added all the weather design inputs. They are here, they are safe. Then design temperatures are simulated on the design conditions we provided based on the summer daily range we have provided. It is going a whole chapter, whole table is now showing up that what would be the maximum and minimum dry bulb and wet bulb temperature, and then there is an hourly view as well for month wise. You can see this is going till December. Okay, so, and again the solar data is found out by the software itself by just these parameters you provided, like the design temperatures, and it is safe in the simulation. Now here, like we have added the Islamabad design conditions, we also need to provide Islamabad simulation data. So that simulation data is not available in the built-in library of HAP. So what you need to do is to download that file, and the link I have shared in the slides. uh, let's find Islamabad. Here the weather data files, they are available. Benazir Bhutto International Airport data file. So you can find. I have downloaded this file Islamabad city because NUST is primarily in Islamabad city H12 sector. So I have downloaded this file, and in this file you can see. Let's actually see that there is a extension of energy plus weather EPW. Now this file, only this file is readable by the HAP. So you need to take this file and import it into HAP. I have already imported it. And for importing the file, you would need to just find it out where it is located and paste it over here. And you should get this dialog box. With this, we have properly integrated the weather condition, the design conditions into HAP. And now the next step would be to define the space for which the cooling load is required to be found. So auditorium, you can name the building. I have named it SMME Auditorium 1. The floor area, for that you need to refer to drawings. It is 46.5 into 51. So let's actually find that out again. Sorry, 46.5 into, okay, it's not working. 46.5 into 51, 2371.5 square feet. So same is integrated over here. Average ceiling height, normally it is 12 feet or 11 feet for Pakistani buildings. If you don't have the section plans, you can just put in these numbers. However, since the section plans are also available, so this is the third floor, and over here from finished floor level to the to the bottom of ceiling, the height is 11.5 feet, 11 feet 6 inches. So let's put it in building weight. Now the next thing is building weight. This can only be provided accurately if a structural engineer provides their input, but normally the trend is that for simple one story, two story buildings, you go with the light type of building weight. For a ground plus 3, ground plus 4 type 4 floors type building, you go to medium, and for high rise building you select this heavy building weight parameter. So I think this is a good estimation. We should move forward with that. It won't affect the calculations as much. Now the space usage, you need to define to the HAP that why you are creating the space, or what would be the end purpose of the space. So in the public assembly area, this is a category, we need to select auditorium. The public would be public assembly. This is an auditorium, and the outdoor air or fresh air requirement is 5 CFM per person, and the second requirement is based on the space is 0.06 CFM per feet square. Whichever is higher, have would automatically integrate the outdoor air requirements, but we will see that later. For time being, you just need to remember that you need to set the parameter of space usage correctly, and this is based on ASHRAE standard 62.1/2010. Coming towards internal, the lighting. So as far as I remember, the auditorium, it is I haven't been there for quite some time, but as far as I remember, it is recessed unvented type of lighting fixtures. So here the SMDs of lights are installed in the ceiling, false ceiling, and as such they are not provided with ventilation. Of course, the heat load coming from such lighting fixture is different from the vented lighting fixtures or free hanging lighting fixtures. So to move forward, let's select the recessed unvented type light, and it is a good approximation to consider 1 watts per square foot. This is the default value, and this is a good approximation, and you can use it. And similarly for blast multiplier, either you can find these things specific to your selected lighting from the literature or from the technical data, or you can just go with the defaults. It won't make much of a difference in the end result, which is to find the total tonnage or total heat cooling load. Now schedule. Okay, for schedules, I have made one default schedule, which is NUT schedule, and the same schedule is now utilized everywhere. Profile 1 is selected. In profile 1, these are hours. This is 12 p.m. midnight, then 1 a.m., 2 a.m., and it goes on like that. So NUST remains operational from 8 p.m. 8 a.m. in the morning to 8 p.m. in the evening, because many evening classes also go on. So let's actually take that. You can also change it. For instance, if you want to make the occupancy level more or less, you want to adjust that as per the requirement, you can do that. For that, you need to be sure of the what are the usage requirements of that space. Right now I am just using this occupancy schedule, and same would be replicated for the lighting and other features. So NUS schedule is there. You can also okay, one more thing, the schedules can be added to project library like this. This is NUS schedule, and once saved, they can be used across multiple parameters. So we were on the space area, space auditorium 1. This we have covered. Recessed unvented lighting, task lighting. This kind of lighting is used when in the workshops or in technical rooms where specific lighting is needed to on an engine or workpiece. So no such lighting is available in the auditorium. Let's not put it. Let's not put anything in it. Then the electrical equipment. Of course, in the auditorium there would be a projector. There would be computer, there would be laptops used to be used by the attendees, and multiple electronic gadgets which do emit heat. So 2500 watts is a good approximation. It's actually a bit of exaggerated, but it is okay. And then again, the schedule is NUS schedule, which I have already explained. The occupancy is taken as 175 people doing sedentary works. So, okay, for argument's sake or for just learning purposes, if this is not an auditorium but a gym and athletics is going on over here, right now you can see the sensible heat per person is 280 BTUs per hour per person, and latent heat is 270. But if we change that activity level, we make them do athletics like in a gym, so the sensible and latent heat part has increased significantly. So you also need to be sure that how much people are going to occupy that space for which you are finding the heat load, and what would be their activity level. And same things also affect the thermal comfort, which I am sure you must have read uh, multiple times by now. So coming towards walls, now only one wall is exposed from sun, which is this side is the north, this is the east, so this is the northeastern wall. Only one side is getting the exposure from the sun. Rest of the walls are within the building, and they are being shared by the other rooms, and one is located with the corridor. So as such, no sun exposure is going to happen over here, because the maximum the maximum uh, exposure would be on this wall. And since sun rises in the east from here, and by following north it goes into the west, it sets in the west, so this wall won't get that much of a sun exposure, sunlight. So if even if it is not included in the calculation, there is no, it is okay, it is negligible. We can move forward with this. Okay,